This is the Chapter 5 review, and we're going to start out by evaluating this integral. Let's add 5/5. We're going to add 1 to the power. That's x to the 2/5, and we're going to evaluate from 1 to 32. And so we have 32 to the 2/5, and we're going to minus 1 to the 2/5. And the way you evaluate 32 to the 2/5 without using a calculator is the fifth root of 32 is 2. So we try to do the root first to make the numbers smaller. And then we have minus 1, so that's 4 minus 1, and we get 3. Here we have a graph, and it says the graph of f of x is shown. Choose the approximations that are greater than, and this would be what the actual answer is, to the area under this curve. So if we have LRAM from -1 to 3, imagine if we just had one rectangle using LRAM. That's an underestimate. The graph chooses the approximations that are greater than. So this one is not. This one is actually less than the actual answer. Trapezoid, and this is concave up. So if we were to use one big trapezoid, then we'd have an overestimate. So this one is greater than the actual answer. And then RRAM, if we change colors here, RRAM would go all the way up to something like this, and that would be the rectangle. That'd be a big overestimate. So RRAM on an increasing function is an overestimate. Derivative of sine of x squared, that's 2x cosine of x squared. The derivative of this is e to the 3x squared minus 4x, but then times 6x minus 4, times the derivative of the inside. The derivative natural log of 4x is 1 over 4x, but then times the derivative of the inside would be 4. Those 4's would cancel, and it ends up being 1 over x. The derivative of inverse sine would be 1 over the square root of 1 minus this thing squared, x squared minus 1 squared, and then times the derivative of the inside, which would be just 2x. So we have 2x over square root of 1 minus x to the 4th minus 2x squared plus 1. And then we'd have 1 minus 1, so the 1's would go away. That's going to be 2x over the square root of, and then we can factor out an x squared out of this. X squared, which would be x squared minus 2. And then the square root of x squared is x. It's actually the absolute value of x, but I'm not going to worry too much about that. Well, let's put absolute value of x. That's x squared minus 2, and then these x's cancel out. So that's 2 over the square root of x squared minus 2. Find the average value of this function over the interval 2 to 3. So we're going to multiply by 1 over 3 minus 2, so in other words 1. Then integrate from 2 to 3 of 3x squared minus 4x dx. And that's 1 over 1, or we're going to end up multiplying by 1, but I at least considered it. And then we have x to the 3rd minus 2x squared from 2 to 3. 27 minus 18 minus, and then we'll plug 2 in, 8 minus 8. So it ends up being, the average value ends up being 9. The derivative of this would be, well, we'd plug 2x in for t. So we'd have the natural log of 4x squared, but then times the derivative of this right here, which is 2. The graph of f of x shown below consists of 2 line segments. What is the value of this integral right here? The area from -4 to 5. So let's get this triangle right here, and we'll make this negative. So -1/2 times 3 halves. We'll call it 3 halves times 3. And then we have this triangle right here that is above the x-axis. So this will be a positive plus. And we're going all the way over to 5. All right, so 1/2 times, that's 1, 2 times 2. And then the height is also 2. And then we're going to add on, well, we would have this rectangle right here, which that half circle is sitting on top of. And that's a 1, 2, 3, 4 by 2. So plus 8. And then we have the area, I don't know why I put a parenthesis there, plus 8. And then we have the area of the half circle. So we have plus 8 and then plus 1/2 of pi times the radius would be 1, 2. Pi r squared, which is 4. I think we got it. Negative 9/4. Half of 4 is 2, so plus, let's just go plus 2 for now. Plus 2 pi. So negative 9/4 plus 8/4 is negative 1/4 plus 2 pi. That's pi. I got it. There we go. Let g be the function given by, the g is the integral from -4 to x of f of t dt. Find g of -1, g prime of -1, g double prime of -1. Find the value or state that it doesn't exist. So g of -1 is the integral from -4 to -1 of f of t dt. So that's area from -4 to -1. So -4 to -1 is the area of this trapezoid, which is negative 1/2. The height is going to be 1, 2, 3. 3. And then base 1 we can call 2. Base 2 we can call 3. So that's, was that a 3? 5, 15, negative 15 halves is what I'm getting there. G prime of -1 is equal to f of -1, because the derivative of the integral is going to be that function. So f of -1 is negative. G double prime of -1 is going to be undefined, because there's you can't have a slope at a corner, so it does not exist. For the function g defined in part A, find the x-coordinate of each point of inflection of the graph of g on the open interval. Explain your reasoning. So from -4 to 3, what do we want? All the points of inflection. So the only point of inflection is at 1. So x equals 1 because f changes from increasing to decreasing. Let h be the function given by this function right here. Find all values of x in the closed interval, -4 to 3, for which h of x is equal to 0. So something to 3 is equal to 0. Well, first of all, 3 to 3 is 0. So x equals 3. X equals, if we start backing up, we have negative area here and the exact same positive area here. So x equals 1. And if we keep backing up, there's positive area here and negative area here that will completely cancel out. So the other one is x equals -1. For the function h defined in part C, find all intervals in which h is decreasing. Explain your reasoning. H of x is equal to, well, let's make it -3 to x of f of t dt. So we're going to switch 3 and x and just make the integral negative. So that h prime of x is equal to the derivative of this, which is negative f of x. And so h is decreasing wherever h prime is negative. And h prime is negative when f is actually positive. So f is positive from 0 to 2. So 0 to 2.